Hello, everyone. Welcome to this session. We're going to start in 2 minutes, exactly at 3:30 Pacific time. See you in a minute. Hi, everyone. Welcome to this current session, The Effects of Temperature on Behavior. My name is Kyle Meng. I'm an associate professor at the Bren School of Environmental Science and Management at UC Santa Barbara in the Department of Economics. I want to welcome all of you to a very exciting session. We have 3 great papers trying to understand both how changes in environmental conditions alter human behavior, as well as how they might alter human preferences in general. Just before we turn to our 3 speakers, here are we're grateful for the collaborators who have made this session possible, as shown here on this slide. And we're also just want to let you know that if you need to resize anything, you can just do so on your screen. Those of you who have been attending all day are probably veterans at this point. So let's just get to the session's main agenda. So we're very fortunate today to have 3 speakers with us: Christos, Makridis, Michelle Escobar, and Remy Levin, who's going to talk about a variety of different projects, all trying to understand how human behavior might adjust, as well as human preferences might adjust to a changing climate. We ask that if you have any questions for the presenters, that you use the Q&A chat function. And what I'll do as moderator is I'll keep a tally of these questions, and I will ask that the presenter give their talks for 20 minutes, and then I will facilitate the Q&A in the few minutes that we have after each 20-minute talk. So our first speaker is Christos Makridis, research professor at Arizona State University, who will present the paper "Split Personalities: Behavioral Effects of Temperature on Financial Decision Making." So Christos, let me pass the mic to you, and I believe you have the ability to drive the slides.
Yep. Thank you so much, Kyle, and thank you for moderating. It's a great group of people today, and for everybody that's joining in. So the kind of intellectual foundation of this paper is based on the recognition that our environment, ranging from the climate to the people that we have in our lives, fundamentally affects the way that we invest, the way that we behave. And I mean, even just thinking like myself, I'm here in New York City for a visit, and it is kind of warm out. It's generally temperate today, but just kind of like being in the going back and forth places, it can kind of drain you. And so I think that there was this very real phenomenon of how you make decisions on a daily basis as a result of these surroundings. And so this paper is joint with 2 good friends, Despina and Anastasia. This is a all Greek team, but it wasn't intended that way. But we've gotten to know each other over the past year and a half. And so just to kind of kick things off, what we know from behavioral finance and behavioral economics is that there are idiosyncrasies within our own personalities, and we're all, very different. And so we want to try to understand how certain personality characteristics might moderate the effects of different types of idiosyncratic shocks. Idiosyncratic shocks ranging from fluctuations in temperature to other sorts of shocks, whether it's an income fluctuation. And the beauty of using temperature is that it's something that is plausibly exogenous as econometricians we kind of think about, whereas an income fluctuation is oftentimes something that is happening as a result of your skill level, the state that you're in. I mean, there's many other factors that are sometimes endogenously determined. And so what we're really trying to understand is how do certain personality characteristics moderate the effect of idiosyncratic shocks such as temperature. We're going to be answering this question by exploiting variation within a country over time. We're going to be looking at the same individual over time and changes in the temperature and seeing how people adjust their financial investments over a period of time. And we're specifically going to be looking at a wide set of European countries and Israel between 2004 and 2018. We have a large sample of individuals, over 140,000. And we're going to be looking at an array of financial investments ranging from bonds and stocks and mutual funds and in retirement accounts. We're also going to have detailed geocoded data at the NUTS 1 level within a country. And we're going to be linking that with temperature data so that we can look at that same individual as they're exposed to kind of different long-run changes in temperature. I think one of the really unique aspects of this data, and I'm going to share a tiny bit more about where this data is coming from, is that sometimes when you're looking at short-run changes, you might not see an effect. But as you trace out the response from an individual for over a decade, you might see how people are really responding. And so what I want everybody to think about, and I'm not going to go into a ton of detail about the statistics here. I want to focus a little bit more on kind of the intuition and the main results. But to have in mind is that much of the variation is going to be from those comparisons of individuals exposed to different temperatures within the same country and over time. So we're going to control for, standard demographic characteristics and try to make these comparisons as comparable as possible. I just want to make a quick point and say that what we're admittedly not introducing like a fundamentally new theory. It's been, we know, and Kyle has contributed to this, and others, obviously in the UCLA conference, have contributed to the importance that temperature plays. But I think what is kind of interesting here that we're trying to do is link a deep finance literature that is about personality and kind of the behavioral finance components of how personality interacts with investment, and then connecting that to kind of the climate economics, the climate social science literature. And as far as we know, this is kind of like the first point that this has been made. Obviously, there's others that have kind of emphasized the role of temperature on student test scores and other things of that nature. But we are building on a larger tradition. And lastly, I'll just point out that there's a number of papers in this last bullet by Bill Goetzman and Zhu and his co-authorships with a couple other colleagues that look at how temperature and temperature fluctuations affect stock returns. And so we're trying to get into why do we see these changes in maybe stock returns, and some of it is because individual financial decisions are made different when there's that volatility. So without further ado, let me just jump into the data, and then I'm going to spend the bulk of the next 13 minutes on the results, and I think the implications that we might want to take away from this sort of research. So in brief, we are using data from the SHARE data set. The SHARE stands for the Survey of Health, Aging, and Retirement that has been done in Europe between 2004 and 2018. Again, the beauty is that we're going to be looking at a large sample of individuals over time. And moreover, we're not looking at people when they're like age 18. So it's not as if, and when you're age 18, maybe you don't have any stock investments. You're looking at people ages 50 and over. And as a result, we're looking at individuals in some of the prime years when they're making these decisions about whether to invest in certain sorts of portfolios. And so the first bullet just kind of enumerates all the different countries that we're looking at. We also see whether or not you invest in stocks or not, and how much conditional on investing you invest. And what's neat here is that there's been a puzzle in the finance literature about why do people not invest more in stocks. And while stock returns are volatile, if you invest in the S&P today and you just hold it for 30 years, you would get a very good return on your money. And so there's kind of the puzzle about why more people don't invest. And so we're going to be connecting that with personality characteristics and fluctuations in temperature. And lastly, we see these demographic characteristics and, importantly, personality traits. And I think for the purposes of the next 12 or so minutes, we're going to focus on a measure of optimism. In particular, what are your hopes for the future? And so there's a couple other personality questions, but basically our measure of optimism is far from perfect, but it's going to be getting at people's general outlook about life. And we're going to be thinking about individuals as being generally more optimistic versus generally more pessimistic. And to what extent does that behave as a moderating characteristic on temperature? We're also going to combine this with kind of standard temperature data, and then we're going to be gathering other data from the World Bank to control for characteristics at a country by year level, such as the labor force participation rate, the GDP growth, and so on, just so that we can control for potential confounding effects. Because between 2004 and 2018, I just think back to Greece. Greece was in a lot of turbulence during those years with the bailout, and so we do want to control for some of those macroeconomic factors. This is, I'm just going to kind of skip ahead some of it, but we kind of go through some of the key summary statistics about the variables that we see. And the only point that I want to make here is just focusing on this top panel where you're looking at different financial investments and looking at between optimists and pessimists. You see, not surprisingly, the optimists tend to have higher investment in bonds and stocks versus pessimists. And so you're going to see these just overall effects where optimists and pessimists are different. That result is not new. We're going to validate those results, but the new results are going to be looking at how does temperature interact with those personality characteristics, and that's where I want to spend kind of the majority of our time. So the main statistical specification that we're going to be running is this regression of whether or not an individual invests in stocks or not, whether an individual invests in bonds or not, and similarly for retirement accounts and mutual funds. And then we're going to take continuous versions of those variables. So the logged amount of investment in stocks, the logged amount of investment in bonds, and so on. And then we're going to regress that on the logged annual temperature. And we're going to interact that as well with the personality characteristic, mainly whether or not the person is an optimist or a pessimist. We're also going to show, actually, I'm going to basically just say this right now, that we find results that are mainly driven by optimism. We find some results when we look other personality characteristics, but it seems to be mainly an effect about optimism. And the reason why that's actually important, and I'll kind of just say this up front because without enough time to go into all the kind of different tables, but there's a lot of theories within economics and finance that are about how do people form expectations. And so the fact that this is more driven by optimism as opposed to something like risk aversion or other personality characteristics is very interesting. And it informs the way that we build macroeconomic models to study asset prices, fluctuations in macroeconomic activity, and so on. The last thing I'll say here is that we're going to be controlling for country and year fixed effects, which is going to allow us to exploit variation within the same country over time. And then we also put in for some robustness exercises, country by year fixed effects, which is going to be controlling for all the shocks that are common across individuals within the same country and year, and just being kind of identifying the psi here based off of the differential effect for optimists versus pessimists. And so in those cases, the temperature variable is going to drop out, and we're just going to be exploiting the variation in this interaction effect. There's definitely concerns with this statistical approach, and that's why we've kind of introduced this panel data to try to circumvent the concerns. So the most obvious one is that there's just unobserved heterogeneity across individuals, and that pessimists and optimists are very different. They live in different countries. They're subject to different macroeconomic pressures, different income fluctuations themselves, and that's why we're putting in those country and year fixed effects. We could also be confounding the fact that changes in weather could alter an individual's stated mood, and as a result lead to differences in kind of financial investment. And so there could be some reverse there could be some reverse causality, but really we're going to be thinking about how fluctuations in temperature might behave as a mechanism for influencing people's financial decisions. And so we're going to kind of think about the mediating effect of temperature. And lastly, as I kind of mentioned before, there could be these time varying shocks that when Greece is suddenly thrust into a financial depression and has to get bailed out by the IMF and other countries, people's portfolios are going to suffer immensely. And so we want to control for those sorts of shocks. So these are, again, just still kind of ways that we're controlling for some of these characteristics or some of these concerns. And just on number 2, we want to think about personality in this context as more of a time invariant measure. So we don't want somebody to answer the survey necessarily in 2004 and then again in 2005, and they're an optimist one year and a pessimist another year. We're kind of taking what we do in short is we take a average and we just look at, okay, if over 50% of the time you label yourself as an optimist and you're an optimist, otherwise you're a pessimist. We do a bunch of robustness to kind of control for that. And frankly, it really doesn't matter. Even if there's some time variation, that's just noise and it doesn't really undermine our results. So now what I want to spend kind of the remainder on is some of these very interesting results. So the first is looking at bonds and the decision to invest more in bonds versus not investing in them. And so what it comes out very interestingly here is that temperature doesn't really seem to affect that much the decision to invest in bonds or not, but the interaction effect between being optimist and increases in temperature does. And so the thing that I want everybody to be thinking in mind is that when there are hotter temperatures, when there is a volatility in temperature, that puts additional cognitive constraints on an individual. And so it might shift their relative preference for investment decision into safer assets. You might be shifted into bonds and away from stocks. And for optimists that are in more cognitively demanding and more complex work sort of jobs, this effect might be more prevalent. And so I know I'm being a little bit wishy-washy on the theory, but in our paper, we actually lay out a simple theoretical model that is consistent with these facts. And so kind of result number 1 is that increases in temperature seem to have a null effect overall, but for optimists, it shifts towards greater allocation into bonds. And it also increases the amount that you invest into bonds. And so this outcome variable is the logged amount invested in bonds. You can also look at this in stocks, and you find the opposite result, that you see a shift away from stocks. And you also see when you look at the logged amount of stocks, you see a shift away from how much somebody is investing in stocks. And so kind of the thing to have in your mind is that as temperature becomes a little hotter, as it's kind of more annoying to be outside, traveling across inside, that induces additional cognitive pressures on an individual. And it seems to be affecting optimists a little bit more. Could be because they're clustered in jobs that are more complex, more cognitively intensive. Now, one of the other neat things that we're able to do with this data is to try to understand what determines this variation in optimism. And so we want to understand a little bit more about the mechanism. And so we look at the role that trust plays, and that more optimistic people tend to also be a little bit more trusting people. We look at the role of risk aversion and the fact that more optimistic people tend to discount risk a little bit more. And then we also look at demographics and health status. And so the main result here is that risk aversion plays a much larger role than just trust in explaining differences in optimism. And so this is just a regression of, are you an optimist, a 1-0 indicator on whether or not you have trust in others, which is a survey question. And then we also control for risk aversion, health quality, other demographics. And it is interesting that risk aversion tends to be quantitatively more important. Obviously, we are finding that trust matters as well, but in terms of the overall economic magnitude, it seems like risk aversion is maybe mattering about twice as much. Now, health obviously matters a great deal. If you're really not feeling well, if your health state is bad, the last thing that you really are trying to think about is how do I optimize my investments? You're thinking about how do I get better? Not surprisingly, being employed is associated with greater degrees of optimism and so on, because that's going to affect your overall degree of self-efficacy and confidence. There's a lot of robustness that we do that I don't want to go into a ton of detail right now. But one that I do just want to point out is you might be concerned that what we're capturing is an income effect, the fact that optimists tend to be a little bit wealthier, that they might be experiencing a surge in income. And so one of the variables in the data set is the property value, somebody's self-assessed property value. And so what we were looking at here was And this is just kind of a balancing test is what in statistics we call it, a coefficient comparison test, a balancing test. And so we take a potential omitted variable, which could be the property value, and then you regress it on the key right-hand side variables of interest. And so basically we show that after you control for country near fixed effects, country by year fixed effects, that there is no statistically significant association between either optimism and temperature and the value of the property. Only in the raw data do you find that relationship. And so it doesn't seem to be that there's a lot of omitted variables that could be driving this result. We also do a lot of work, and this is something I'm not going to go into a ton of detail right now, but we do a lot of work to look at heterogeneity across countries. And so we look at countries that tend to rank higher versus lower in terms of trust. And being from the Mediterranean myself, think about Italy and Greece and the levels of trust there versus maybe in some of the Nordic countries. And so what we find is that the interaction effect is kind of present in panel A, where we're looking at higher trust countries. And so it does suggest that obviously trust matters, and that individuals that are in more cognitively intensive jobs and also optimists, that there is some complementarity between these different personality characteristics. So we're not trying to say optimism is all that matters, trust doesn't matter. There is some sort of complementarity there. And the last thing I guess I want to do as I kind of move towards conclusion and open it up for Q&A is that one of the neat results I have in a paper with Jason Schlachter at Georgetown is we're looking at how does fluctuations in temperature affect people's level of well-being and their life satisfaction. And what we show is that there's a bit of an inverse U-shape where on really hot days, on really cold days, it tends to make people a little bit more pessimistic about their life. And so one of the mechanisms in this paper is most certainly that systematic increases in temperature might affect people's mood, and that will influence their decision about how much to invest and the amount of risk that they're willing to take on. And so with that, and again, actually that's deeply connected with stock returns and explaining the inverse U-shape that you see in stock returns. So think about this as kind of the microeconomic evidence behind some of these other stylized facts that other people from finance have pointed to before. So with that, I think I have like 30 seconds or maybe maybe I'm at time, and just kind of conclude and say, we know that personality characteristics matter, but what we know a lot less about is how personality interacts with other idiosyncratic shocks. And so the approach that we've tried to take in this paper has been to look at a very specific type of idiosyncratic shock, namely fluctuations in temperature over the long run, and see how that might be moderating and influencing the effect on financial investments. And so we find the bottom line is that we find that hotter temperatures push optimists towards safer assets and away from the riskier assets of stocks. And we find really no effect on pessimists. And so in the actual paper, we lay out a theoretical foundation for why you would expect to find that. And we have data that's consistent with those theoretical predictions. So with that, I will kind of leave it here for any Q&A, and just appreciate any feedback, any questions, and your attentiveness.
Great. Thanks a lot, Christos. Thanks for sharing that. Let me just open up the floor to any questions from the audience. If you have them, you can just type it in your chat, and then I will facilitate it. And so while people are doing that, Christos, let me ask you a question. So one of the things that strikes me as I was listening to your talk is like, okay, so you're thinking about financial decisions, but it's not clear to me what is the right mix of stocks and bonds that we should be expecting. So, and furthermore, it seems like the right mix is going to be different for different age profile. At least that's like what my retirement fund tells me, almost paternalistically. So I'm curious, like in these results, like how do we interpret what is correct and what is incorrect, and so by some measure. And if the optimal mix of stocks and bonds is going to be different for different age groups, isn't that something those two outcomes, isn't that something you want to jointly estimate? Like maybe something like, instead of separate regressions, estimate like, stock, dollars in stock over dollars in all, or something like that, or some kind of like, joint outcome that captures the kind of binary choice between those two investment vehicles.
Yeah, no, that's a really insightful question, because obviously the portfolio that each person holds is going to depend on their appetite for risk. It's going to depend on macroeconomic conditions and all that. So, I mean, we were kind of just thinking about how this shock might shift your relative profile without taking a stance on necessarily what's going to optimize your financial future. But I think that there could be, yeah, actually, and this is maybe we're going to think about this more. I might send you an email about how, I mean, you gave an example of how to maybe address this and maybe to kind of jointly estimate it. I think it's very tough to kind of figure out like what is that optimal allocation. And I mean, obviously financial advisors don't always get it right. And so we were just trying to avoid some of the guesswork that comes with that. Now, because we have a panel, we can vote, we can kind of assess what is maybe ex post what turned out to be a good decision based off of how things turned out in that country. And so looking at things in 2004 and then tracing out over the Great Recession, and we might have some very neat variation because it's such a stark swing for each country when you think about what Europe went through during the financial crisis. So I think that's a great question, and we need to do a little bit more thinking about how to operationalize that.
So let me relay a question from Michelle, who's presenting next. Michelle Escobar asks, could optimists and pessimists deal with high temperatures differently? And let me just add an addendum to that. Can you tell us in your data set exactly how optimism or optimists and pessimists are defined in your data set?
Yes. So I'm going to talk while I'm going back a little bit. So we're constrained by just with any observational data, just like what's in the survey. And so one of the actual comments that we got at an earlier point was maybe you don't want to define this as optimism, but in more of a think about being hopeful or whatnot. So one of the survey question is around what are your hopes for the future, and so that is kind of and so there's a potential to say you're kind of expecting good prospects, and so that's kind of our main question. And then we have a question about whether you felt sad or depressed, and so we label that as depression, and then one about enjoyment and overall general interest. And so I think that's kind of the logistics of how we're defining it. The question about how do people respond differently, I think that, I mean, very much so. And we're kind of just assuming that that's captured by the direct effect in the regression. But as you think about different dynamic decisions that people make, it could be that they decide to relocate in different areas. And that's where the panel variation is very important. And we're able to exploit person-specific variation. So I think, so in some of these columns, we put in, so we have person fixed effects. And so for that, that will trace out for a given individual how they're responding over time, and trying to difference out the sorts of factors.
Let me relay a second question from Michelle, who asked, can you add controls for cloud cover and precipitation to make sure you isolate temperature effects? Because we know those things can be correlated.
Yeah. No, that's a great question. I believe that we were in the process of getting precipitation data because this was something that somebody else asked about, and so we're going to add that as a control. And I need to double check if that's in if these coefficients reflect that, because as we kind of all know, especially using U.S. data and exploiting like day-to-day fluctuations, sunlight and precipitation, cloud cover are other very correlated variables.
While we wait for other questions, Christos, one question I have, I'm still thinking about through the, I'm not familiar with these survey questions, so I'm still thinking about the interpretation of an optimist and pessimist. It strikes me that answers to those questions could reflect in some sense almost like, time preference. And if so, we would expect people of different time preferences holding risk fixed maybe to have a different investment profile. Is that one possible interpretation of the results, or do you think there's one that's more about optimism, pessimism that's separate from time preference?
Yeah, that's great. So I think in our data set we don't have a phenomenal measure of. I'm trying to see if I. So I don't think I have the result in these slides, but so in the survey, we don't have a great measure of time preferences. We have a decent measure of risk aversion, but what we do have is some other finance researchers had published a paper in Journal of Economic Psychology that they basically launched a large-scale survey to create a measure of hyperbolic discounting and time preferences separate from risk aversion at the country level. And so what we do is that we just kind of run split samples, and we run our regression separate for the kind of high discounting countries and the low discounting countries. And I believe that the result from that was that there wasn't any big differences in those two samples. Where we were finding a little bit more was in these trust versus low trust. And then we also looked at Western Europe versus Eastern Europe because of the kind of decline in the Soviet Union and how that might have had persistent effects.
Great, thank you. Great, we're right on time, Christos. Thank you so much. Thank you for that presentation. That was a really interesting paper. And I'm just gonna now pass on the mic to Michelle Escobar. Was a PhD candidate at Monash University, calling from Australia, and she's going to talk about temperature and economic preferences in developing countries. Michelle, the floor is yours, and you have 20 minutes.
Thank you very much. Well, good. I was going to say good morning, everyone, because it's morning here, but good day to you all. My name is Michelle Escobar. I am a PhD student at the Monash University Center for Health Economics, and today I'm going to be presenting joint findings with my co-authors David Johnston, Rachel Nod, and Rohan Sweeney, also at Monash Uni, on the effects of temperature on economic preferences in developing countries, in Indonesia in particular. So I want to start by motivating this talk by, just a sec, I'm not sure that, yeah, there you go. So I want to start by motivating this talk by talking about what sort of the economic literature tells us about how willingness to take risk and patience affect our behavior. So we know, for instance, that individuals who have a higher willingness to take risk are also more likely to open a new business or to become entrepreneurs, to uptake new and innovative products. At the same time, we also know that impatient individuals are more likely to save and have positive savings and to invest, for instance, in health and education. In the neoclassical theory, these preferences towards time and risk are assumed to be static, but there is a very exciting new strand of the research in the economic literature that shows that these preferences are in fact malleable with exposure to negative shocks such as natural disasters, financial crises, even extreme violence. So in this paper, what we're going to do is that we're going to study whether temperature could be another potential factor that is influencing preferences, even if it's just in the short term. And we're going to study three mechanisms: cognition, sleep, and mood. And this is motivated by two different strands of literature. So one shows that all of these three channels directly influence economic preferences. So for instance, a study among Chilean students shows that those with higher math skills also have lower time discounting rates and lower risk aversion. Other studies show that better and higher quality sleep decreases discounting rates and decreases loss aversion. And a number of studies also show that higher aggression, so anger, increases financial risk-taking and propensity towards other risky behaviors, such as risky driving. And the second strand of the literature shows that temperature in turn affects cognition, sleep, and mood. So for instance, Park et al. Show that a higher number of hot days decreases the rate of learning and skill formation among school-aged children. Another study using approximately 7 million nighttime observations shows that higher nighttime temperatures decrease sleep duration by delaying the time when we fall asleep. And a very recent paper using data on prisoners in the state of Mississippi shows that more uncomfortably hot temperatures increase the propensity towards risk. So we're going to be joining these two different strands of the literature, and we're going to be showing that they have very different predictions. So for instance, all of these different channels would predict an increase in impatience, so higher discounting rates. The cognition and sleep channel would predict an increase in risk aversion, and the anger or aggression channel would predict a decrease in risk aversion. So just a sec, my slides are taking a while to move. So we are contribute to a very growing broader literature, but in terms of which specific papers have looked into this very specific question, there's three papers that we could find. So the first is by Almas et al., who runs a laboratory experiment on university students in Kenya, in the US, in California. And they find no evidence that heat stress significantly affects risk-taking or time preferences. A slightly older study by Wang shows that higher ambient temperatures increase high risk and high yield options in financial investments. And then a study by Chima and Patrick finds that individuals that are operating in warmer temperatures are the opposite. So they are less likely to gamble, they are less likely to purchase innovative products, and then they also have lower cognitive scores. And I think that we can all acknowledge that the strength in this laboratory approach is that they are able to address selection biases by randomizing people into high temperatures versus low temperature. However, they also have very important weaknesses. So for instance, they have very limited sample sizes. The sample composition also raises questions on how generalizable these findings can be. But perhaps more importantly is the time of exposure to treatment and duration of exposure. So imagine for a second that the reason why temperatures could be affecting preferences is through nighttime temperature. So they are decreasing the quality or the duration of sleep. And because these studies are not randomizing overnight temperatures, then they wouldn't be able to capture these effects. The issue on duration of exposure is very similar. So imagine that the reason why this relationship exists is a product of a cumulative effect of heat. So 15 to 20 minutes or an hour of high temperatures in the laboratory might not be enough to trigger any significant effects. So we're going to address these relevant gaps by using data from the Indonesia Family Life Survey, which is representative of approximately 83% of the Indonesian population, the one that lives on the eastern side of the country. And we're going to be using the last 2 waves out of 5 waves that are collected every 3 to 5 years. And this is going to give us approximately 50,000 individuals with the 2 waves combined. So from IFLS 4 and IFLS 5, we obtain our main outcome variables, which are risk aversion, gamble aversion, and impatience, which I'll explain in the next slide. And from IFLS 5, the last wave, we obtain data on the different mechanisms. So in this slide, you observe the different instruments that we use, and I'm not going to bore you with the details, but what I want to point out is that in the time preferences flowchart, so you're going to be offered a choice between a certain amount of money today and another amount of money in the future, tomorrow, for instance. And this is going to be a series of questions where each additional question offers a higher reward for that future value. And we're going to create a binary variable that captures whether you're in the least patient or most inpatient category. And that's approximately 62% of our sample. On the risk preferences flowchart, this follows a very similar model where you're offered a choice between a certain amount of money, a sure amount of money, or a gamble. And this gamble entails a 50-50 chance of getting an X times smaller or a C times higher amount from that sure value. And with this, we're going to create a measure of most risk averse. And that's approximately 37% of our sample. But what's really interesting about this particular model is that the first question offers you a choice between, say, for instance, $8 for sure, or a 50-50 chance of getting $8 or $16. And what you can observe there is that the probability-based option offers you at least as much as the safe option. So it would make sense, even if you are a very risk-averse person, to go with the gamble. And however, in spite of that, 31% of our sample still chose the safe option. But we wanna keep those people, and we wanna study them because this would represent some sort of rational choice violation that we would be very interested in knowing whether temperature is influencing that. So the next step that we take is that we validate these 3 different measures using the approach by Falk et al. With a global preference survey. And what we do is that we show that people in the most inpatient category are less likely to have savings and less likely to have higher schooling or higher education. And then we also show that those individuals that are either in the most risk-averse category or in the gamble-averse category which was the rational choice violation, are all correlated with a lower propensity to make risky choices. So it looks like this gamble-averse category is not capturing, for instance, that individuals don't know what's happening, don't understand the model or the question. So it's valuable to keep this gamble-averse, even if separately. We then complement these data with data from NASA's MERA tool, from which we obtain measures from environmental estimates. And what we do here is that we have the GPS coordinates of the villages. So we assign each village to the closest MERA grade, such that every individual is going to live within a 50-kilometer radius or less of the nearest MERA grade. In terms of our identification strategy, what we're going to do here is that we're going to exploit quasi-random variations in temperature caused by the random allocation of individuals into survey dates within a province. And we showed that this is a plausible claim because individual and household characteristics do not significantly explain maximum temperatures or nighttime temperatures on the day and night prior to the survey. And then in addition to that, as you can see in this graph, an important feature of this design is that in order to roll out the entire instrument within a province, it took approximately 150 to 300 days. And this is going to give us temporal variation in temperature. However, I could imagine that you might have a number of potential concerns if we simply compare any and all individuals within a province. So we go a step further and we build beans that are capturing several microclimates, and these are based on the 4 key factors that affect temperature: altitude, latitude, distance from the sea, and level of urbanity. So we know, for instance, that latitude significantly influences temperature. So for every temperature decreases by 1 degree for every additional 100 meters of altitude. And at the same time, we know that altitude is also associated with low socioeconomic status and poorer physical health, which could in turn affect preferences and shorten your time horizon. Latitude, which is the distance to the equator, also has a negative relationship. So as you move further and further away from the equator, temperatures drop. But we also know that latitude influences economic output, settlement patterns, disease environment, which similarly could affect time and risk preferences. Distance to the sea also positively influences temperature, but we also know that people who live closer to the coast potentially have very different wealth profiles and adaptation strategies, and all of these could be correlated with time and risk preferences. And finally, level of urbanity, we know it's associated with the urban heat island effect, which is when we replace green spaces with surfaces that absorb and retain heat. But at the same time, we know that people who live in urban and rural areas have very different wealth and risk profiles, and this could also be affecting our economic preferences. So what we do is that we create these microclimates. So we generate 285 beans, which are the result of interacting the province where you live, a dummy indicating whether your area of residence is urban or rural, 4 altitude groups, and 3 distance to the coast groups. I think this is clearer if we see it in a map. So as you can observe here, this is the province of North Sumatra on the left side of your screen. And this ends up with 19 different types of beans. So what we observe here, and I think it's very interesting, is those purple circles. Those are individuals living in villages that are considered to be rural within under 50 meters of altitude and within 3 kilometers of the coast. So they have very similar microclimates, but the variation in temperatures that we'll be exploring comes from the fact that they're spread around the entire province, which is going to assure that they would be surveyed over many, many weeks and potentially months, and that's going to give us a variation in temperature. So what you observe here is that precise within bean variation, and as you can see, there's enough there for us to perform our calculations and run our models. And I also want to point out the fact that temperatures in Indonesia are consistently high. So during the survey period, maximum temperatures were on average 29 degrees, but they could go all the way to 40 degrees. And nighttime temperatures were on average about 24 degrees, but could go all the way to 29. So here what you see is just that formal equation where we not only add the bin fixed effects, but we also add month fixed effects to control for seasonality, year fixed effects to control for broad climate changes, and we also control for precipitation, wind speed, and pollution in the form of particulate matter 2.5 microns. So our beta temperature is going to take 3 different forms. We're going to look at maximum temperature on the day of the survey, temperature at the hour when the survey began, and nighttime temperatures on the night prior to the survey. So that's exactly what you see here in when we estimate the linear effects, panels A, B, and C. And what pretty much jumps at you is that none of these measures of temperature significantly affects risk aversion. However, they do significantly increase gamble aversion and impatience. Now, we also know that all these measures of temperature are potentially positively correlated, but hopefully not perfectly so, that we could in theory try to distinguish which of these are more important. So what we do in panel D is that we use both maximum temperature and midnight temperature on the night prior to survey because they have the lowest correlation coefficient. And we find that midnight temperature entirely dominates here. So this would suggest that nighttime temperatures are more important in terms of affecting your economic preferences. We then estimate a more flexible specification, and what we find here is that these effects are pretty much quasi-linear, with an inflection point at around 25 degrees for gamble aversion and 22 degrees for impatience. We then look at whether these effects could vary by different subsamples, but we find no significant differences by gender and age. However, we do find that individuals with lower schooling and those in the bottom half of the consumption distribution experience larger increases in gamble aversion and impatience as a result of higher nighttime temperatures. We then look into the mechanisms that I spoke of at the very beginning, and we, as I mentioned in IFLS 5, we have different measures of cognition. So we run regressions on each and every one of them, but we also create a global cognition score using principal components analysis. And overall, what we find is that every additional degree of nighttime temperature significantly depletes all forms of cognition, except for mental intactness, which is a TIC's Z-score value there. We also find, however, that temperature does not significantly affect our measures of sleep or mood. And I think the caveat here, especially with those sleep measures, is that we know that self-reported measures of when you went to bed and then when you woke up have a very low correlation with actual sleep efficiency. So we take these results with caution. Finally, we look at evidence of cumulative effects. So as I mentioned earlier, it could be that it's not necessarily the one day prior or the one night prior or the day of when you're doing the exercise. It could be the result of many, many days of exposure to high temperatures. So this specification, what we do is that we create a binary variable that captures whether the temperature the night before was above 25 degrees, that relevant inflection point, and we interact this with the number of nights in the past week above 25 degrees. And the first thing that you observe here is that, first of all, that interaction is not significant, but what seems to be more relevant here is that cumulative exposure to many nights of high temperatures. We finally run a number of robustness checks. So, for example, we exclude 19% of the sample who were interviewed over more than one day, who could potentially self-select into cooler days or cooler time slots. We also test what happens to our coefficients when we control for individuals who were surveyed over Ramadan. Humidity, we control for interviewer fixed effects. We run a placebo test using a 14-day temperature lead, and coefficients remain stable. So, okay, let's go to the conclusions. What we find here is that nighttime temperatures are significantly increasing gamble aversion and impatience, and they are increasing risk aversion, but only when we use that IFLS4 sample. We also find that these effects are quasi-linear in nature, with significant inflection points at 25 degrees for gamble aversion and 22 degrees for impatience. And we find that nighttime temperatures are significantly depleting cognitive functions, but math skills in particular. So we presume that individuals are having to rely on lower level processing functions and are therefore defaulting to safer options. And then we also find that individuals with lower schooling and in the bottom half of the consumption distribution are more affected. Finally, in terms of what are the implications of these findings, it's important to note that these are short-term effects. However, we also know that we make many decisions throughout every single day, and some of these short-term decisions could have long-term implications. But in terms of the long-term implications of global warming or higher temperatures more consistently, that's something that our specification and our study is not able to respond to immediately, but it's important to ask whether these temperature effects could become more permanent with global warming. Thank you.
Great, thank you, Michelle. Again, to the audience, the floor is open for questions. There's one question from Remy, who is our next speaker, and yes, Michelle, if you're explaining the timing of the survey rollout, are you using climate data going back to 1981 or just recent data from 2007 to 2014?
Yeah, that's a good question. Thanks, Remy. So we're just using temperature data from 2007 to 2014. So, well, in fact, 2006, because we also, in other specifications, we include tests for whether temperature in the past could affect your current preferences. But I just wanted to illustrate that the MERA2 dataset has data since 1981, so you could potentially do other cool stuff with it. But in this specification, it's just 2006 to 2014.
Thanks. So Michelle, I have a question. I find your effect, so if I understand one of your tables correctly, you're getting a lot of your action from midnight temperatures from the night before.
That is correct.
Which is very interesting, and that suggests to me there's like a sleep channel from which this is occurring. But then, interestingly enough, you don't pick up any effects on the self-reported sleep variables like onset. I forgot what the other ones were, and so I'm curious. Like you have mentioned that those variables may not be very reliable, but do you think there's something there in terms of it being going through the sleep channel? Because I can't imagine what else is happening at midnight except for most people are sleeping or not sleeping because of the heat.
Yeah, that's still my operating hypothesis, even though the sleep variables are not really capturing any significant effects. And I think what's interesting as well is that as we saw when we do this within bean variation, the nighttime temperatures are also like the variation left there. It's very small. So when we expand and do a more flexible specification and we go a little bit at a higher level, then we do see effects on sleep of nighttime temperatures on sleep. So I think that perhaps we just maybe don't have enough power and enough variation in order to capture those sleep effects. And that combined with the fact that self-reported measures of when you went to sleep or when you woke up are not really capturing sleep quality, I think that could be the issue there. So yeah, we're trying to do additional work on this, but we're limited by what the data allows us.
One thing I was thinking of that I think is very fascinating, as you pursue this potential mechanism is, we know that climate-controlled environments provided by air conditioning help ameliorate a lot of these effects, but they're expensive. And in fact, most people can't afford or don't have the infrastructure to be able to either afford the fixed capital of an air conditioner or to pay the marginal cost of electricity to run it. And one of the things that I think your research is helping us think about is like if you have a finite budget, right, for air conditioning, where do we want to spend it? I think most people would say up to this point, like you turn it on during the day because that's when, it could be most helpful for our labor productivity, but insofar as sleep is very important and it helps us, in terms of these various measures for the next day. There's an interesting question now of like, well, do you turn it on at night to ensure better sleep, or do you spend that amount of kilowatt hours to, air condition during the day? Anyways, it's very interesting. I hadn't thought about that consideration before.
Yeah, no, I totally agree. And I think especially in Indonesia and in other developing countries that are consistently hot, you see that in office spaces, that they're increasingly purchasing air conditioning units. So that would indicate that the optimal thing to do for on a household level would be to allocate that air conditioner use at night, because anyway, during the day, you're going to be protected to some extent. So yeah, that's a really great point.
And there's also just to follow this, there's also interesting of where the cost burden goes through. So if it's during the day, maybe the cost burden is borne by the employer, though maybe some of that incidence is passed through wages. But if it's at home, then it's purely going to be borne by the household. And so then there are interesting considerations about the equity consequences of who's paying for adaptation when, and especially when they have differential returns.
That's an awesome point. Yeah.
Any other questions from the audience? Great. Well, in that case, thank you so much, Michelle. That was very interesting work. Thank you for sharing that with us. And so let me introduce our final speaker. Let me just pull up the slide if I can. Remy Levin, who is a visiting assistant professor at University of Connecticut, who is going to present a paper called Risk Preference Adaptation to Climate Change. All right, the floor is yours, Remy.
Okay, thank you, Kyle. So thank you all so much for joining. Sticking with the symposium towards all the way to the very end. So as Kyle said, my name is Remy, and I'm a visiting AP at the University of Connecticut. My research agenda focuses on understanding the ways that risk preferences adapt to changes in the environment. And I'm very excited to present to you today my new work. Let's see if clicking goes. 1 second. I'm very excited to present to you my new work called Risk Preference Adaptation to Climate Change. And this is joint with my good friend and colleague, Wesley Howden, who is a postdoc at the University of Arizona now. So we start this paper with the following idea. We all know, given that we're in this Climate Adaptation Symposium, that climate change involves significant uncertainty about the future. That's not a controversial statement. But given that fact, it stands to reason that risk preferences, in fact, affect the optimal response to climate change. And that's not just kind of an intuitive point. This is also a point that literature, especially recently, has been validating more and more, including work by some of the participants in this symposium, right? It's a little controversial what exactly the effect of risk preferences are on our response to climate change and things like the social cost of carbon, but it seems increasingly clear that they do in fact affect how we should respond to climate change. Now, when we think about the relationship between risk preferences and the response to climate change, we tend to make a standard assumption that Michelle highlighted as well, and that's that preferences, and particularly risk preferences, are fixed and unaffected by the environment. And of course, I don't mean to beat up on climate econ specifically. This is a standard assumption that we make in economics generally, that preferences are fixed. But in this paper, we're going to argue essentially against this assumption. And we're going to try to show that, in fact, lifetime experiences of climate change do directly affect individual risk preferences and individual risk aversion. And to do this, we're going to proceed on three prongs, right? So this paper has three big parts. The first one is a decision theoretic model of how exactly risk preferences might adapt to the environment. And I'll just give you a very quick sketch of that here. So we think in this model of an expected utility maximizer who's exposed to two sources of risk. One endogenous source of risk that's under their control, and one exogenous and statistically independent background risk that they can't control. So if you'd like an image of what I'm thinking about here, you can think of, say, a farmer in Indonesia or Mexico that comes to their field each year and is making a decision between planting a risky cash crop versus a safe food crop. That's the foreground endogenous risk that they're making a choice over. And they have to make this choice of which crop to plant in the presence of, say, climate risk that will affect the yield and perhaps the prices of the crop that they're planting. Now, in this model, we make the standard assumption in the background risk literature that these two sources of risk are substitutes for the agent. What that means is that the more risk exists in the environment, the less risk the agent is going to want to take in their own individual choices. So that's a standard static background risk framework that I just described to you. We combine this background risk framework with a model of learning over the background risk. Specifically, we think of an agent who perceives the background risk as being a stationary Gaussian random variable, but one that crucially they know neither the mean nor the variance for. Instead, they observe realizations of the background risk over their lifetime. As they observe those realizations, their beliefs about both the mean and the variance of the background risk adjust over time. And as their beliefs over the background risk adjust, their preferences over the foreground risk adjust in turn. So that's the basic of the model. And what we get out of the model is the following two predictions. The model predicts that foreground risk aversion, the agent's preferences over the endogenous lottery, are going to be related to changes in the moments of the background risk that they experience. Specifically, if the mean of the background risk goes down, the agent's risk aversion will increase, or rather decrease, sorry. So foreground risk aversion will decrease in the mean of the background risk, and foreground risk aversion will increase in the variance of the background risk. So given this model, we then, in the paper, take this model to the data. So we start with two large panel surveys, one from Indonesia and one from Mexico. The total N of the two is about 25,000. And the thing that's special about these surveys is that each one of them contains two elicited measures of risk aversion for the same subjects several years apart. And in our primary empirical analysis, we combine within-person changes in these measures of risk aversion with changes, subnational changes at the subnational level, at the state level, in the agent's lifetime climate experiences. So by this, I mean that we look at lifetime experiences of temperature and precipitation and the means and variances of those variables and how they change, and look at the effects of that on changes in measured risk preferences for these individuals. I'll get into more detail about how exactly we do this in just a little bit. So what do we find when we do this? Well, generally we find results in line with the predictions of the model. So in both settings and across both climate variables, we see that increases in the temperature and precipitation mean lead to decreases in risk aversion for subjects in both countries. We also see that increases in the variance of temperature lead to increases in risk aversion in Indonesia, and increases in the variance of precipitation lead to increases in risk aversion in the subject pool in Mexico. And one thing that I want to emphasize about these results is that we can see the relative effects of the mean and variance in the setting. And it's very clear from these that the variance effects that we're picking up are first order. So the magnitude of the variance effects that we see is between 0.7 and 1.6, the magnitude of the mean effects. So our focus on variance and thinking about the tails is very much motivated by the theory of risk aversion, but empirically it's also validated by the magnitude of the effects that we see. So that's the second piece of the paper. And then finally, in the last piece of the paper, we asked the question of whether these preference changes, these empirical preference changes that we see are in fact adaptation or just change. And in order to answer that question, we developed a new method to estimate whether changes in risk preferences are in fact adaptive. The way we do that is that we rely on new developments in the welfare literature to show that the changes in risk preferences that we see in some settings increase welfare under certain assumptions, and therefore are in fact adaptive and not just changes in preferences. And when we use this method, we yield two primary estimates. We see what we call overall risk preference adaptation. This is the adaptive effect of all preference changes, regardless of whether they're driven by climate or not. And then using our primary empirical specifications, we also estimate the climate-induced preference adaptation. In other words, for the components of risk preference change that's affected by climate specifically, we can estimate whether that change is in fact adaptive or maladaptive. And what we see when we do this is the following. So first of all, we see, and very interestingly, we see differences in whether the overall risk preference change in both settings is adaptive. So our results indicate that in Indonesia, the risk preference change that we see increases between the waves of the survey, increases welfare overall by about 6%. And that's an indication that the overall change in preferences is adaptive. In Mexico, on the other hand, what we see is that the changes in measured risk preferences imply in our method a decrease of 8.2% in welfare. In other words, those changes, those overall changes in risk preferences are in fact maladaptive in the Mexican context. But also interestingly, when we isolate the climate-induced component of the change in preferences, in both settings, we see very consistent results. We see that the climate change-induced change in risk preferences is adaptive in both settings and accounts for about a 1% increase in welfare. So we conclude from this that the climate change-induced changes in risk preferences that we observe, in fact, do represent adaptation by the subjects to in our study to the effects of climate change. So that's the overview of the paper. In the remaining time, what I'm going to do is focus primarily on the empirical results and on the welfare results, the welfare and adaptation results. So for our empirics, starting with our sources of data, we in Indonesia, as Michelle is doing, use the IFLS. It's one of, if not the highest quality family life survey in developing countries that exists today. Our sample is limited to individuals born after 1976, when we start having the fine-grained climate data that's available to us. And because we're using with in-person changes to estimate the effects, we restrict the sample to individuals who are both in IFLS 4 and IFLS 5, which are the survey waves that have the risk preference measures that we use. We also use the Mexican Family Life Survey for Mexico, and there, since we've got since Mexico is in North America and data availability is for climate variables is less of an issue, we can go farther back for the analysis. So we can cut the sample for individuals born after 1940, but again, we restrict the analysis to those individuals that show up in both surveys and for whom we have repeated observations of risk aversion. Then for climate data, we use gridded data sets. In Indonesia, these are two slightly different data sets. They're very consistent with each other, GHCN CAMS for temperature and GPCC for precipitation. And these show up at the half degree by monthly level. In Mexico, we use Livne et al.'s CONUS grid data set, which again is more fine-grained, about 6 kilometers at the data. So for empirical analysis, let me just walk you through very quickly the construction of our main variables, starting with the dependent variables. So, thank you very much, Michelle, for kind of setting this up. So this task will be a little bit easier to explain since we've kind of gone through it very quickly. So in both surveys, we've got hypothetical high stakes choices between a sure amount of income and a 50-50 gamble between a higher and lower amount. So the enumerators literally come into the village and they ask Kyle, who in this analogy is an Indonesian villager, would you prefer $100 for sure, or would you prefer a 50-50 gamble over $50 or $200? Based on Kyle's initial choice from the lottery, he sorted into one of two other lotteries where the amounts of the gambles are changed. He answers that question again, and once we've got several of these answers, we can sort all of the subjects into bins by measured risk aversion. This ends up being an ordinal measure of relative risk aversion for the subjects. Now, one thing that I want to highlight with this data is that this data has, this specific kind of survey data has several advantages for estimating the question that we're trying to estimate here. Generally, we tend to think of hypothetical questions as perhaps less credible than kind of real-world measures of risk-taking. But in fact, it turns out for estimating the effects of experiences, this kind of data has distinct advantages over things like choices of, say, portfolio shares, or other kinds of data that we might think of in the real world for estimating this question. And these advantages are as follows. So first of all, in these survey questions, the odds and payoffs of the gambles are known to the subjects. And that's really crucial because if we're trying to identify the effect of climate experiences on preferences, one of the primary identification challenges we face is that what might be changing over time is not the agent's risk preferences over the endogenous or foreground lotteries per se, but rather their beliefs about the returns of the lottery. So if I was going to use portfolio allocations, for instance, to identify risk preferences, maybe what's happening when I see changes is not that the agent's risk preferences are changing per se, but their perception about the returns of different portfolios or different stocks and bonds might be changing. That concern is not an issue with this kind of data, which is a big advantage. The other big advantage is the fact that these lotteries, the choice themselves, the choice that the agents are making themselves, that we're using to estimate risk preferences over, are exogenous to the agent's own lotteries, or own history rather, right? So what do I mean by this? Well, again, with something like portfolio allocation, if we're trying to estimate the effects of experiences on risk preferences, experiences might actually be influenced by the choices that an individual makes over time as far as how they allocate their portfolio, like which stocks or bonds they might be exposed to over time, right? Which is a very tricky identification problem for estimating the effects of experiences. Now, in Jonathan Colmer's earlier talk, he talked about one way to kind of solve this problem, which is looking at single events that are plausibly exogenous, which may kind of deal with this issue. But we are particularly interested in the effect of cumulative lifetime experiences, long-run changes on risk preferences. And so that doesn't really help us just looking at hurricanes. But instead, the fact that we have this lottery data that's exogenous to the choices that people are making over time, that goes a long way towards solving that very tricky problem of estimating the effect of experiences on preferences. Okay, so that's the left-hand side of the regressions. What about the right-hand side of the regression? So the climate variables. So what we do here is that we construct monthly temperature and precipitation series by state for each one of the subjects. In our primary specification, we're going to use state of birth to avoid endogenous migration, but we have robustness where we use state of residence and actually track subjects over time. Generally, what this involves is matching grid data to state and province boundaries and collapsing those time series that are available to state-by-month panels. Once we do that, we assign subjects to climate time series from birth to measurement. So what I mean by this is, imagine that you were born in 1992 in West Java. For the observation of you in IFLS4, we will assign to you the West Java time series from 1992 to 2007. And for the observation of you in IFLS5, we will assign to you the West Java time series from 1992 to 2014. So from birth to measurement in both cases. Once we have these time series assigned, we'll calculate the experienced mean and the experienced standard deviation of temperature and precipitation. And our main independent variables are going to be the changes in the lifetime experienced mean and the changes in the lifetime experienced standard deviation of each one of the climate variables between the waves of the survey. So what does this data look like? So here I've plotted for you just the raw data on temperature and precipitation in Indonesia and Mexico in terms of the moments, the changes in the standard deviation and the changes in the mean for each one of these variables. And each one of the dots in these graphs is a cohort in our analysis. So that means a group of people who were born in a given year in a given state in the data. Now, we've color-coded this data to go from blue to red, where blue captures older cohorts in the data and red captures younger cohorts. And there's a few things that I want you to notice in this data. Aside from the fact that the Indonesian heat data looks like a squid. So one thing that I want you to notice is that the data is spread out over all 4 quadrants for both climate variables and in both settings. In other words, we have subjects in our subject pool that are experiencing increases or decreases in the mean, so heating or cooling or wetting or drying, and subjects that are experiencing stabilization or destabilization in these climate variables over their lifetime. So what does that mean? It means that the effect of climate change is actually very heterogeneous as far as the way it affects people over their lifetime. So we tend to think of climate change as maybe just a heating trend, but in fact, we see a lot of heterogeneity in the data. The other thing to notice is that there's a sprinkling of blue and red dots all over the distribution of the data. In other words, it's not the case that just younger cohorts or older cohorts are the ones that are experiencing certain kinds of changes in the moments. There's quite a bit of variation in the changes in the moments relative to the cohorts that are experiencing them, which also helps us with identification in this case. As far as our empirical specification, it's relatively straightforward. So we think about first differences. These are changes. On the left-hand side, we've got changes in measured risk preferences. And on the right-hand side, we've got changes in the mean and changes in the standard deviation of these climate experiences over people's lifetimes. We include subnational inflation in all regressions to account for the fact that there's differential inflation and therefore the values of the lotteries themselves are changing over the course of the survey. We cluster the standard errors at the state of birth by birth year level, which is the treatment variable that we care about, or treatment level that we care about. One thing to mention is these are single differences, but since we only have 2 periods, this is equivalent to having individual fixed effects and time fixed effects in the regression. So what do we get from running these regressions? So this table right here is really the main results in the paper, and there's several things that I'd like to point out to. And as I do notice the scale of the p-values that we've got for these results. So one thing to notice is that the mean effects that we see in the data are consistent for the effect of mean temperature and mean precipitation on measured risk preferences in both settings, right? So all of these coefficients are negative in both Indonesia and Mexico, and both for heat and precipitation, and they're quite significant. The other thing to notice is that the effects
Sorry,
of...
Remy, can I just ask that you wrap up? Thank you. Sorry,
Yes.
We're just running out of time. Thank you.
Absolutely. So the effects of variance are positive in both settings, and we can compare these magnitudes, and we see that the effects of variance are first order. We have additional analyses in the paper. We look at controlling for other types of effects, and we look at other kinds of behavior, but in the interest of time, I'll just move on to the welfare and adaptation results. So in the last couple of minutes, what I want to talk is about this new method for detecting climate adaptation. So we start with this notion that even though we often think that adaptation just means change in the climate literature, strictly what adaptation is change plus increases in welfare. So what that means is that changes in welfare are instructive about adaptation, but changes in welfare are with changing preferences are quite non-trivial, right? So our approach is going to be to take our empirical measures of risk preferences at face value. And we're going to do that in the following way. There's this very nice result from a recent paper by Maya Eden last year in the JPE, showing that under expected utility assumptions, we can always generate a welfare criterion for a group of people, even with heterogeneous risk preferences, known as the equally distributed equivalent, so long as we're given the distribution of consumption and the distribution of risk preferences. What we're going to do is we're going to structurally estimate the distribution of risk preferences in our data, assuming CRRA utility. And then using our main regression results, we're also going to estimate the counterfactual set of preferences that individuals have in the latter period, or would have had climate change not occurred. And once we do that, we can get a measure for the overall change in welfare from realized changes in risk preferences and the climate-induced change in welfare from changes in preferences. And of course, these results are sensitive to the structural estimation, which is why in the next slide, I'm going to show you spec charts that show how these results change depending on the choices we make. And the main thing that I want you to take from here, so in these spec charts, the triangles are going to be the climate-induced risk preference, climate-induced risk preference welfare changes. And these little vertical lines are going to be the non-climate-induced risk preference changes, or changes in welfare due to risk preferences. And the main thing that I want you to take away from this is that in both settings, the triangles are above the zero line, which means that we see evidence of positive adaptation to climate through changes in risk preferences, even though the overall adaptation or overall change in risk preferences increases welfare generally in Indonesia and decreases it in Mexico, which entails adaptation in Indonesia and maladaptation in Mexico. So just to wrap up, what do we do in this paper? I think we provide the first direct evidence that lifetime changes in climate risk directly affect individual risk preferences. And one thing that I think is kind of special about what we do here is that we focus on long-run experiences, not one-off events. And what that allows us to do is separate and scale and aggregate tail effects and body effects, right? So these results are not just about extreme events, they're about both extreme events and more usual events and how they relate to each other. And that hopefully will give us a better prediction of effects given worldwide, what we expect to be a significant amount of worldwide heterogeneity in climate change and climate experiences. And then finally, we developed this new method for detecting whether the changes in preferences are in fact adaptive using these empirical risk preference measures. So thank you very much. I know I'm a couple minutes over time, but thank you so much for having me.
Great, thank you, Remy. In the interest of time, I'm afraid we're just gonna have to skip the Q&A for this paper and just open it up for a more general discussion of the series of papers, these 3 papers that we have seen. So those in the audience, feel free to type in your questions, and this need not be for any particular paper, but for our whole panel of Christos, Michelle, and Remy. So feel free to do that. And while you guys are doing that, we have a few minutes. Let me, I guess, pose a question for the panelists. One of the things that strikes me is with the unifying theme, if you will, of these papers is that you're trying to understand, local temperature effects on some kind of behavioral measure. And in some papers, these are interpreted as kind of cognitive limits or challenges to people making economic decisions, like in the case of Christos' paper or in the case of Michelle's paper. And then in others, like in Remy's paper, the interpretation is that it's not so much cognitive challenges, but rather it's revealing a fundamentally different preference parameter. So I'm curious how, if that can be separated, right? These are 2 separate entities. One is saying we have some given preference parameter and we have trouble making decisions consistent with that parameter or consistent with our behavioral theory. The others are saying, no, we don't have any problems, but we are actually recovering a different preference parameter. So I'm curious from the panel, because you guys have thought about this more than I have, how do you think about trying to separate these 2 explanations for these results?
Yeah, I think that's an excellent question, Kyle. So, and this is something that I've thought about a lot, right? Because I've been thinking about these preference changes. The first approach, I would say, of thinking, oh, we have a fixed preference parameter and something is getting affected by, say, cognitive effects or other effects. That's kind of the more standard approach in the economics literature, right? And I think that's perhaps the one that's a little bit more comfortable for us as economists, because that's how we're trained. But I do think that that approach is being challenged by the new data sets that are coming out that seem to be measuring on their face what you or I would call risk preferences or any other kind of preferences, right? So if we saw these kinds of measures in the lab, we would say, look, these are measures of risk preferences. And I think perhaps the most defensible, to my mind, the most defensible thing to do given observing changes in these measures is to take those changes at face value. And once you do, it actually opens up a whole set of questions about what might in fact affect preferences. Rather than kind of sticking to this fixed preference perspective that we've kind of gotten used to over the last 40 years. So that's my personal take on this question.
I like how we've gone to the point where a behavioral econ explanation is now the standard go-to explanation.
That's right.
That's okay. So Michelle, I'm curious on your thoughts on this question.
Honestly, I hadn't thought of it that way. In my mind, it was a thing about more how that both can be happening. That both an immediate shock can be temporarily changing your preferences, and then they might or might not bounce back. So I think what we're not making the assumption here that that these preferences should, for in any case, bounce back to a fixed sort of preferences. I think what we're only saying is that what we're able to capture here are short-term changes, but we don't know if these changes are permanent or not because of data limitations. So I'll probably have to think more about this, because in my mind, it was more of a, both are plausible scenarios.
It's interesting. There's obviously a distinction between temporary and permanent changes, but one interpretation of your response, Michelle, is it could be that it's as if there was a change in preference, right? It's almost like as if like we don't actually think consumers are actually utility maximizing, but we observe behavior that is as if they were utility maximizing. And maybe one answer to my question is, from a policy standpoint, if whether it's a cognitive difficulty or change in some primitive preference parameter, as long as it's as if it's like the latter, then that would suggest like implications in terms of optimal policy design. And maybe an as if argument is sufficient here, maybe not. That's actually something that would be interesting. Okay.
So, can I just say one?
Yeah, very quickly. We're almost out of time. Sorry. Go ahead.
So I generally agree with you that the as if versus actual preference change for many applications doesn't matter. But I do want to point out with this kind of idea of detecting adaptation, it does in fact matter whether the thing that's changing is the preferences. So there's a sense in which once you allow for preferences to change, perhaps there's some utility to doing that. And one of the things that we were hoping to do with this paper is demonstrate that utility through this idea of trying to detect adaptation in this specific context. Understood.
Yeah. Okay. Well, thank you very much, Remy and Michelle and Christos. So I think we're out of time here. This is for those who are tuning in tomorrow. Here are the sessions tomorrow. A lot of very interesting topics again as it relates to climate change adaptation. And finally, just thank you all for joining us today. Okay. Thanks a lot. Take care.
Thank you very much.
Goodbye.